We're going to continue to look at simplifying radicals, and this time we're looking more closely at the quotient property of radicals. So we don't want any fractions underneath the radical sign or in the radicand. So in order to do that, we're going to go ahead and break up our fractions into two separate radicals. So in our first example, it says square root of 13 over 100. I'm going to break that up into two radicals, square root of 13 over square root of 100. I'm going to look at the top number, 13. If you remember, 13 is a prime number, which means we can't simplify that radical any further, so we're going to leave that. But 100 is a perfect square, so we can take the perfect square of 100 and we get 10. And that's as far as we can go with that problem. We'll take a look at the second one. It says simplify 18 over 4, and all of that is under the radical. We can go ahead and divide 18 by 4, or instead of that, maybe simplify it into 9 over 2. That's one way we can go about it. Or, and there's nothing wrong with that, but there's more steps to do after that. So one thing we want to do is go ahead and break this up into the two radicals like we did for our first example. Right off the bat, I can see that in the denominator, I have the square root of 4. That's a perfect square. I can take it. It's 2. Now my top number, 18, that is not a prime number. It's not a perfect square. So I'm going to need to pull it off to the side and go ahead and do my prime factoring. Now under the radical, I have a single 2, and then I have a pair of 3's. These 3's are square root of 9. The square root of 9 is 3. I'm going to write that in front. And then I have 2, which stays under the radical. I'm just going to reinsert that into my fraction on the top and call it a day. We do always want to take a look at any numbers here outside the radical that we could maybe simplify, but in this case we cannot. Let's take a look at a few others. We might need to simplify our radicals by rationalizing the denominator. And that means that we have a radical in the denominator and it can't be simplified. So what we're going to do is create a funny little fraction with that radical number. Square root of 7 over square root of 7. Whatever that radical is in the bottom, we're going to make a fraction out of it. And we're going to use it in both the top and the bottom. Now remember, when you multiply, I can multiply numbers outside of the radical with other numbers outside and those inside with those inside. So here I have a number outside and one inside the radical. So this just becomes 5 times radical 7. On the bottom, under the radical, 7 times 7 is 49. You should recognize that now you've created a perfect square in the bottom. So we can keep going with this. The square root of 49 is 7. And that's where we'd stop. And again, we want to look closely at those numbers outside of the radical to see if we can simplify them. In this case, we cannot. Our next one, for rationalizing the denominator, gives us quite a big fraction here with lots of different pieces. So let's take a close look. It says, hint, hint, simplify all radicals first. Okay, well, I can't simplify radical 5 because it's a prime number. So I'm going to leave that be. But in the bottom, I can work on the square root of 24. I'm going to pull it out over here. And I can simplify that. 2, 12, 2, 6, 2 and 3. So that becomes 2 times 2 times 2 times 3. Here's a pair. And then these are single guys. I can multiply them, but notice that 6 is not a perfect square and I can't simplify it. Square root of 4 is 2. So on the bottom, I actually have 2 radical 6. Right away, you should be able to recognize that these 2's out here can be simplified. 2 divided by 2 is 1. So they kind of cancel each other out. So here I'm left with radical 5 over radical 6. We're not allowed to leave a radical in the bottom, so we're going to rationalize it by multiplying it by root 6 over root 6. Now I can multiply numbers under the radical with other numbers under the radical. So 5 times 6 is radical 30, and 6 times 6 is radical 36. We should recognize that on the bottom, in the denominator, the square root of 36 is 6. Now what about the top? Can we simplify 30? I'm not sure, so I'm going to pull it off to the side. I mean, I think I can, but I'm not sure until I try it. Let's see. 3 goes into 30 10 times. 2 and 5. Up. I've got only single numbers here, no pairs of numbers. So that tells me that 30 actually is already simplified. So my final answer is square root of 30 over 6. Please note that you cannot divide the square root of 30 by 6. You can't simplify that because the top is in the radical and the bottom is not. We're going to take a look at 4 extra practice problems to simplify our radicals. For the first one, I've got square root of 9 over 16. So that's a fraction in a radical. Can't happen. We're going to go ahead and break it up into 2 separate radicals and see if we can simplify. The square root of 9 is a perfect square. Awesome. That's 3. The square root of 16, perfect square. That's 4. Done. 3/4 is my answer. We'll take a look at letter E. It looks like it's simplified, but there's a radical in the denominator. So we have to multiply by that funny fraction that we create with that radical. We're going to multiply straight across the top. We get 1 radical 2. And on the bottom, radical 2 times radical 2 is radical 4. I can keep simplifying. The square root of 4 is 2. And then my question is, do I really need that 1 out in front? The answer to that is no. So you could leave the 1, or you could erase the 1. But then this is your answer. No more radical in the bottom. And the radical we do have can't be simplified further. Next one. Again, we can go ahead and multiply with a radical. Or we could have simplified the radical first. I'm going to go ahead and show it this way. On the top, we get 6 radical 12. And on the bottom, we get radical 144. We know in the bottom that the square root of 144 is 12. So I'm going to go ahead and pause myself right here and say, hey, what do I notice right there? That fraction, 6 over 12, can be simplified to 1/2. So now I have this. And just like before, do I really need that 1 out in front? Not really. So I'm going to erase it. But my radical 12 can be simplified. So I'm going to pull it off to the side and do my prime factoring. I have a set of 2's. That gives me the square root of 4 times the square root of 3. And the square root of 4 is 2 radical 3. Now I can go ahead and put that back in my fraction, and I'm going to replace the whole top with that. So 2 radical 3 over 2. Oh, what do we notice here? This could be simplified further. So my answer is really square root of 3. Now we could have simplified the square root of 12 to begin with, and then use that as my, my simplified radical, and use that to rationalize. There's a lot of different ways you can start these problems. We're going to take a look at the last one. It says root 20 over 9. So again, I'm going to break it up into 2 radicals. And recognize right away that in the bottom, I have a perfect square. So I don't have to rationalize this one. I can just take the square root of 9 to get 3. But I should recognize I still have a radical in the top, and we have to check to see if it can be simplified further. So I'm going to pull that one out and work on my prime factoring. And rewrite it as 2 times 2 times 5. That one's the square root of 4 times 5. And the square root of 4 we can take to be a perfect square of 2 radical 5. So now when I reinsert this into the top, I get, whoops, I don't get that. What I do get is 2 radical 5 over 3. And that's as far as we can go for that one. I'm going to just show a couple other quick examples. You might see questions like this where you have 2 radical 3 times 3 radical 5, and maybe even a third one. Maybe this one's just 2 radical 4. Now let's do 2 radical 5 again, like this. Keep in mind that you can only multiply numbers outside of the radical with other numbers outside of the radical. So 2 times 3 is 6, times 2 again is 12. We can also multiply numbers under the radical with other numbers under the radical. 3 times 5 is 15, times 5 again gives us 75. So far this is what I've got. If I continue with it, I want to go ahead and do my prime factorization here. And I'm going to say 3 times 25, that's what I recognize, and then 5 times 5. Square root of 25 times square root of 3, the square root of 25 is 5 radical 3. So again, I'm just replacing square root of 75 with this, but what you should recognize is there was already a 12 out in front, so my 5 also goes out in front, and it's strung together by multiplication. So this would be 60 radical 3. So you might see a problem like that. You might also see a problem that looks like this. What if I had 2 radical 5 squared? Well, we talked about what exponents mean in our previous unit or section. That just means write the base how many times? 2 in this case. So this is really 2 radical 5 times 2 radical 5. When I work on that, I get 4 radical 25. And the square root of 25 is 5. So I really have 4 times 5, which is, let me put it over here, 20 for my final answer on that one.